video is going to go over questions 23 through 29 on the exam 2 review sheet. All of these questions ask us to simplify the radical expression. Now this first one says the square root. So whenever we're looking for the square root of a number, we're looking for what number times itself equals the number that they ask about. So this one says the square root of 49. So if we think about the number 49, we know that that is 7 times 7. So the square root of 49 is 7 because we have a pair of 7s. Okay, next it says x to the 6. So let's write that out. We have 1, 2, 3, 4, 5, 6 x's. Remember, we're looking for pairs. So we have 1, 2, 3 pairs of x's. So the square root of x to the 6 would be x to the 3rd power because we have 3 pairs of x's. Now we have 8 y's. Let's write it out. 1, 2, 3, 4, 5, 6, 7, 8. Again, we're looking for the square root, so we're trying to make pairs. We have 1, 2, 3, 4 pairs of y's. So the square root of y to the 8th would be y to the 4th power. So our answer for this question is 7 x to the 3rd power, y to the 4th power. Alright, now the next question asks us to find the cube root. So the cube root means we're looking for groups of 3. So we're not looking for pairs anymore like on the square root. Now we're looking for groups of 3. So 27 can be broken down into 3 times 3 times 3. 3 cubed is 27. Now let's write out our x's. We have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, we're looking for groups of 3. So I have 1, 2, 3 groups of 3. So the cube root of x to the 9th would be x to the 3rd power. Next it says I have y to the 11th. We want the cube root of that. So we write out our y's. 4, 5, 6, 7, 8, 9, 10, 11. So I have 1, 2, 3 groups of y's, and then I have 2 left over that don't fit into a group of 3. And then finally the z's, we have 19 of them. Now I'm not going to write that out. I know that if we have 19 z's, that we can make 6 groups of 3 with 1 left over, because 3 times 6 is 18, and then we'll have 1 left over for that 19th z. So my answer for this one is going to be 3. I have 3 groups of x's. I have 3 groups of y's. Remember we talked about we have 6 groups of z. Now, on the inside, don't forget that little 3 for the cube root. We had 2 y's left over, so they'll stay inside. And we had 1 z left over, so that 1 z stays on the inside. So our answer to this question is 3x cubed, y cubed, z to the 6th power, cube root, y squared, z. Alright, number 25 is not quite as easy because it gives us numbers this time that aren't perfect squares. So now we have to think about what is a perfect square that can divide into the number that they give us. So first we have 5 square root 80. Now I know that 16 is a perfect square, and 16 divides into 85 times. So I can rewrite this as 5 square root of 16 times 5. Now we're going to do the same thing with 45. 9 is a perfect square number that can divide into 45. So I have 7 square root of 9 times 5. 9 times 5 is 45. Minus, this time we have a 50 under the radical, and 25 is the largest perfect square number that can divide into 50. So we have 6 square root of 25 times 2. 25 times 2 is 50. Now we're going to go ahead and simplify these radicals. So I know that the square root of 16 is 4. So I'm going to rewrite this as 5 times 4. 5 does not have a square root, so I'm going to leave that in the inside. All right, the next one I have 7, and I know that the square root of 9 is 3. And once again, 5 is not a perfect square, so that's going to stay on the inside. All right, the next one, I have a 6. The square root of 25 is 5, and 2 is not a perfect square, so that's also going to stay on the inside. Okay, now let's go through and let's simplify. 5 times 4 is 20, square root 5. Minus 7 times 3, that's 21, square root 5. And then the last one, 6 times 5, that's 30, square root 2. All right, now we look to see if we have any like terms. Like terms means they have to have a matching radical. So we see we have two terms, the first two terms, which have radical 5. So we have 20 square root 5 minus 21 square root 5. That gives me negative 1 square root 5. 20 minus 21 is negative 1, and then we're just going to bring along the 30 square root 2. We cannot combine those together because they have different radicals. And that's it. All right, question 26. We are multiplying. We're going to be distributing. So first, I'm going to take the 2 square root 3 times the square root 3. 2 square root 3 times square root 3 would be 2 square root 9. Now I'm going to take 2 square root 3 times 4. I'm distributing, which is 8 square root 3. All right, now I'm going to move on to this negative 5. I have negative 5 times the square root of 3. So that's going to be minus 5 square root 3. Then I have negative 5 times positive 4, which is just negative 20. Okay, so we're looking good. First thing I recognize, though, is that this first term has a square root of 9, which we know the square root of 9 is just 3. So we can rewrite this first term as 2 times 3. Now, I also recognize that those are like terms. They both have a square root of 3. So I can combine those. 8 square root 3 minus 5 square root 3, that is 3 square root 3. Then we have a minus 20. Okay, still I can simplify this 2 times 3, so now I have 6 plus 3 square root 3 minus 20. And then the final thing that I can do is I can combine the 6 and the minus 20. 6 minus 20 is negative 14. And then we'll just bring down our 3 square root 3. All right, question 27. Same thing. We're going to be distributing, but let's look at this one closely. We have 7 plus the square root 2 times 7 minus the square root 2. So we're going to be multiplying conjugates together, and it's going to be important for us to recognize what happens when we multiply conjugates. Let's start. First, we're going to do 7 times 7. That's 49. Next, we're going to do 7 times negative square root of 2, which is minus 7 square root of 2. Okay, next we're going to take the square root of 2 times 7, which is plus 7 square root of 2. And finally, we have the square root of 2 times negative square root of 2, which is a negative square root of 4. Okay, now I notice that we have some like terms, these middle terms. We have a minus 7 square root of 2 and a plus 7 square root of 2. And we should know that those are going to cancel. Okay, we also need to recognize that the square root of 4 that we have down here at the end, we know the square root of 4 is just 2. So now this problem became really easy. We have 49 minus 2, which is 47. So it's really important for us to recognize that when you're multiplying conjugates together that have square roots in them, it makes all of the square roots disappear. Our answer no longer has a square root, it's just a whole number. All right, question 28 and 29 have to do with radicals that are inside of fractions. And the rule is it's improper to have a radical in the denominator of a fraction. So we need to know how to rationalize the denominator. So in number 28, we have a square root of 11 in the denominator of our fraction. And in order to get rid of that, we're going to multiply the numerator by the square root of 11. And we're going to multiply the denominator by the square root of 11. So now we have 5 square root of 11 over the square root of 121. And we should know that the square root of 121 is just a plain old 11. So now we've gotten rid of the square root in the denominator and we have a proper fraction. All right, number 29. So we're going to go back to what we learned on number 27 about conjugates. Remember, when we multiplied by a conjugate, it made the square roots disappear. So since we have the square root of 5 minus the square root of 3 in our denominator, we're going to multiply by the conjugate of that to make the square roots in the denominator disappear. So I'm going to take this on the denominator, and I need to multiply by the square root of 5 plus the square root of 3. And I'm going to do the exact same thing in the numerator. Remember, it's okay to have a square root in the numerator. Okay, now we need to start distributing. So first, I'm going to do the numerator. I have the square root of 5 times the square root of 5, which is the square root of 25. And then I have the square root of 5 times the square root of 3, which is the square root of 15. Now let's do the denominator. I have the square root of 5 times the square root of 5, which is the square root of 25. Square root 5 times square root 3, which is square root 15. Now I'm moving on to the negative square root of 3, and I multiply that by the square root of 5, which is negative square root of 15. So now those are going to cancel there in the middle. And I have the negative square root of 3 times positive square root of 3, which is negative square root of 9. Now I need to start to simplify. So in the numerator, I have the square root of 25, which is 5. And 15 is not a perfect square, so we can leave that as plus the square root of 15. In the denominator, we have the square root of 25, which is 5. We see that square root of 15 minus the square root of 15, that cancels. Then we have minus the square root of 9, which we know is just 3. So now we can still simplify the denominator because we can do 5 minus 3, which we know is 2. And in the numerator, we have 5 plus the square root of 15. So now we've done our job. We no longer have a square root in the denominator.